All right, so in our previous video there, we were solving for angles within one circle. Okay, so now in these questions here, we're going to be solving for solutions that are beyond a circle and they beyond any domain. Like if we don't give you the domain, then we have an infinite number of solutions. So we're going to find out what we call general solutions, where they are, as long as the angle lands on the exact same terminal arm, that angle will satisfy the equation. So there are an infinite number of solutions to all these questions, like the ones above it. But those ones above it, we were limited ourselves to our specific domain, 0 to 360, negative pi to 2 pi. So we're limiting our answers to those spots. But what if I don't? How do I express that? Okay. Well, they start off the same way. So you solve these questions just like you would solve one of those previous questions. But once you find your answers, then you have to talk about the coterminal angles and how we determine that. And we did that before where we just added 2 pi or subtracted 2 pi or added 360 or subtracted 360 to find those coterminal angles. And those would be your solutions. So we're going to pull back. We're going to go to that video and pull back that kind of question when we talk about coterminal angles and expressing all of them as a general solution. So to solve some of these, now some of these are a bit weird, like this one here has sine and cos in it. There's no difference between this and the previous kind of video. In this situation, I would say you could write a let statement. You don't necessarily have to write a let statement, but I'm going to write a let statement here, sorry, where I'm going to say that cos x is w and sine x is, let's go with z, okay. So here I have 2zw plus, or is equal to, is equal to 3z. Okay. So how I'm going to solve this is going to make it equal to 0. Now by adding z's and w's, it might make it a little bit harder to look at, but I just having fun here, I guess. So I have these two situations, and to make this equal to 0, you can either say, okay, if z was 0, then this whole thing would be 0. And if w was 0, then this whole thing would be, or sorry, this whole set of brackets here was 0. So if z was 0, or if w was 3 over 2. Now I said that z is x, sine x. So sine x could be 0, or I could say cos x is equal to 3 over 2 because that's what w is. Now, cos x 3 over 2 does not work. There's no solutions again. We had very similar solutions from before. This is greater than 1. It doesn't work. Now we look at sine 0. Sine is 0 because this is the y value in these two terminal arms, the quadrantal angles. So x, it's not theta, but this time we're talking about x. X is 0 degrees or 180 degrees. Okay. That's within one circle. But I can keep on going around here. I can say, okay, I got 180. Oh, I can go to 360. There's another one there. I can go even further and go to this one over here and go to 540. Right? And I can keep on going. So what we're going to do now is we're going to try to figure out, okay, how do I represent all of these angles that I keep on going around the circle, over and over again. So this is where we pull our coterminal angle knowledge back and say x can be, now I always want to pick the smallest positive coterminal angle. So I'll start off with 0. We're talking about in degrees here, so that's good. We're in degrees. So that's why I put a little degree symbol there. And then I'm going to say add, and the coterminal to 0 is 360, and I could add a bunch of them, so a bunch of n values there. And I can go backwards as well. I can subtract 360. Or I can have this one as well, because I had two angles, the two solutions here. Now what I can do here, I can recognize the pattern. I can say, oh man, there's a pattern. All these angles are 180 degrees apart from each other. 0, 180 plus another 180 plus another 180 plus another 180. So I can combine these together if I wanted to. Like this is fine. Like what I just wrote here, that's a perfectly valid solution. You find the two answers within the first circle, and just plus 360 n NEI. which is going to add 360 at both of those angles. And that's fine. That's a solution, right? But a nicer solution would be if you combine the two and say, okay, I'm going to start at 0, and I'm going to add 180n instead. And that would give me the exact same solutions. And 0 plus, you can get rid of the 0 plus, you can just write 180n. Because n could be 0, right? Because it's an integer. Integers can be 0, so that could be 0 if I put a 0 in where the n is. It could be 180, it could be 360, depending on what n value I have there. So these are both pretty good solutions because they kind of reduce down the pattern a little bit. And sometimes what you want to look for, sometimes you want to look for that pattern, but both of those solutions on the left or right there are just fine by me. This one or that one. Okay. Our next one here, just close that down on the other side over here. We're just going to do the same thing. We're just trying to determine our general solution. So before I start, I'm going to say let cosecant x, let's make that equal to y, just so I can solve this. Y squared minus 2 is equal to 3y. They're both equal to cosecant, yeah. I'm going to have a square in there, so what I'm going to do is I'm going to minus over the 3y. It's a quadratic. Look for a GCF. There's no GCF here, so I am going to factor this. All right. Well, it multiplies out to 4 and adds to 3. So probably 4 and 1. Negative 4 to get to the negative 3. Yeah. Reduce this one down. Yep, looks pretty good. Okay, so y could be 2 or negative a half. Okay. So now what I'm going to go back up here and replace the y with the cosecant x. So cosecant x is equal to 2, or cosecant x is equal to negative a half. Okay. Now I'm not going to cross out the cosecant x is equal to 2 because I'm allowed to do this one because this is 1 over sine, and then this turns into a half. So that's possible because this sine is less than 1, so this is a good solution, so I can solve that. This one I can cross off, though, because I do the same thing, and then I'll get sine x is equal to negative 2. That's no solutions on that one because that's bigger than 1. You could try that. Take the sine inverse. Okay, so sine is positive in 2 quadrants, and also this is a 30-degree reference angle, sine a half, 30 degrees, and it's positive in these 2 quadrants. Add sugar to coffee. Okay, and we're in radians, but let's just deal with x first in degrees, and then we'll change it to radians. So we got 30 degrees and 150 degrees. So this would be 180 minus 30 for that one. Okay, so I determined my 2 principal angles within the first quadrant, right? So my 2 solutions, they're both principal angles because they're less than 360. They're both positive. But now I want to do it for all my real numbers. But first of all, I'm going to change these to radians. Okay, so I got pi over 6 and 5 pi over 6. You could do that quickly in your calculator. So my solutions here are going to be pi over 6. Now I could have this pi over 6, or I can go around, or I can go around, or I can go around again and again and again and again, right? So there's lots of different solutions here. So I'm going to add 2 pi n and ei. So that could add or subtract 2 pi. And then I'm going to have the 5 pi over 6, because again, I can go to 5 pi over 6, or I can go around again, and I can go around again, I can go around again. So I'm going to add 2 pi n and ei. Now you look at these two and say, is there a pattern? So if you draw them out, it's sometimes easier to see the pattern, or if you look at the angles between them. So it goes 30, and then this, if I get from here to here, what would that be? That'd be 120, right? And then you'd want the pattern to continue on, like 120. If I add 120, do I go back to the one that was over here? No, this over here on that side is a lot bigger than 120. It's actually 240. Yeah, it's 240. So there's no pattern between the two. It goes 120, 240, 120, 240. Well, that's a pattern, but it's not a consistent number. So this is my solution here. There's no way to condense these down into one thing. Okay? Let's try another one. Sometimes, like, you might get a solution where, I was mentioning that on the side here, maybe you'll get 3 solutions that look like this, right? 2 in the top quadrant, 1 in the bottom. And if you look at the angle difference between them, you could have 120 between all 3 of these. If you get something like that, then you condense all 3 of these down into one thing. You don't have to have 3 different solutions because they're all the same. So I can go, well, it depends on what the first one is. Let's say it was 30 degrees. I can go 120, N, NEI, and represent all of these as one, right? Let's put that as a side note. So that could show up. You can condense these down and look at the patterns. Maybe you can just combine 2 of them and then the third one's out. All right, so maybe from 3 solutions, you can bring it down to 2 solutions instead. In this case, if it was all 120s all the way around, you could take all 3 of those and make it into one. Algebraically determine the solutions here. So because tan is the only thing there, I'm just going to rearrange for tan. So divide the 4 over, take the square root. Because you did it, you had to put the plus or minus there. So there's 2 solutions here. No, it'd be nice if that was a 2 rather than a whatever. Okay, you could make this equal to 0 and then factor it like a difference of squares. That's fine too, and you get the plus or minus. So we have the 2 answers here. We got tan x is equal to positive a half. We get tan x is equal to negative a half. Sometimes you can get 4 answers, you can bring it down to 1 as well. I'm going to get 4 answers here, but I don't think I can bring them down to 1 solution. So tan is positive in this quadrant and this quadrant. Tan is negative in the 2nd quadrant and the 4th quadrant using my add sugar to coffee rule. Oh, I said add sugar to coffee, but then I wrote them wrong. It's weird. Ah, poop. I keep on hitting the button on my pen here. It doesn't work sometimes. Add sugar to coffee. Okay. So you're going to do the tan inverse of a half. Not a very nice number. It's like 26.5. It's not repeating. But I'm going to put that in my calculator. Yep. Put that in my calculator. X, this is X reference, is 26.565 degrees. Okay. So that reference angle is here for all of these. They're all the same because they're all halves here. Okay. And now I'm going to combine them together. So I'm going to have this one, and I'm going to put it to the nearest, well, once it's in radians. Yeah, I'm going to just go with the degrees, and I'll change it to radians in a bit here. X is going to be 26.565, and 180 plus that answer, 206. Yeah, once it's in radians. 206.565. That's for the first one. And then the second one here, same reference angle. I'm going to go 180 minus this answer. $153. 435. And then go 360 minus this answer. Oops. 360 minus this answer. 333. 0.435. Okay, so we have all our 4 solutions here. Now we have to think, is there a pattern? if I were to draw these all on here, I'd realize there is a sum up pattern. Like between these two at least, here to here, that's 180, 180, 180. And from these guys, it's also 180, 180, 180, 180, right? There is no pattern between all four of them because it would be like 52 degrees here, and then up here would be a little bit larger, be 100 and something. All right, so there's no pattern between all four, but I can condense at least these two down. I'm going to go to the nearest degree. Oh, so the nearest radian here. So let's change this to a radian. So this as a radian, times it by pi divided by 180. Yep, 0.46, I'll go to the 100th here, plus not 2 pi. Because they're 180 apart from each other, I'm going to plus 1 pi n ei. So at least I can condense that one down. And then this side over here is going to be, I'm going to change that. 153 times by pi divided by 1 is 2.68 times, times 10, so 2.68 plus pi n nei. So again, we can condense these two down because there's a pattern between them. It's plus pi each time. And the pattern between these is going to be plus pi each time as well. So going back and forth between them. So there we go. That ends up this lesson. Hopefully this lands in a good spot during the week, and you can do a quiz, an assignment, do all that stuff. And I'll see you in the next lesson, the next chapter.